So hello everybody, I think it's time to start our webinar. I welcome you on behalf of Airport Research Center for this webinar, Airport Challenges of the New Entry-Exit System, EES. I have this presentation today with two colleagues. So Mark Illing is a colleague of mine of Airport Research Center, and Frank Steffens is our guest today of the company Seconet, who is a facility provider for entry-exit systems and a solution provider. And I'm very happy that they are with me today, that we can introduce you to this very exciting and challenging topic of the new entry-exit system. So I would like to give you a short introduction of the agenda. So first of all, I will give a brief company introduction of ARC and CAST, the ones who don't know us and who are not familiar. And I would like to give an introduction to the entry-exit system, give an overview, what does it mean? Then I will talk about the capacity impact by using simulation to show what is the impact of introduction of the entry-exit system. I will show two scenarios. One is do minimum, what we know a lot of airports are still thinking they could act with. So not adding additional handling positions, but just try and work with it like it is a little bit higher processing time, but still facilities could work with this. And then also look into a scenario, what does it mean if we need to build more booths? So what is needed to prevent chaos. And then I will hand over to Seconet for the process optimization with self-service technology. So they are the experts in this area, and they will give some more technical insight how this works. And after this, my colleague Mark will show you best practices and lessons learned from case studies. So we did several projects in the area of entry-exit in recent years. And it's still an interesting topic because a lot of things are not known and there's a lot of uncertainty. And I think we can present some approaches how to tackle this uncertainty. I will also give a brief outlook on operational support. This means how can simulation also help you when you once introduced entry-exit system to better handle this system. And then if we have some time, we will also give some questions and answers. First of all, if you have questions, please put them in the not in the chat, but in the question and answer part, and then we will collect them and answer them at the end of the webinar. Thank you. Okay, so let's start with a brief company introduction. So our company is based in Aachen in Germany. We are a consultancy which is specialized in airport planning and simulation. We are since more than 20 years on the market and have a lot of experience in the aviation industry. Our company consists of 50 experts for airport planning, capacity assessment, and optimization. And we have around collected in this 20 years more than 150 worldwide aviation clients. So we are present all over the globe in each continent, although we are a small company. And this is also because we are the developer and distributor of the simulation software CAST, which is widely used by a lot of airports worldwide. Just to give you some more introduction, so our field of expertise, so we are not only a software provider, but also a consultancy, what I said. So we are active in the field market analysis and forecast. We also work on master plans and designs. And then we have a department where I'm active in, so for capacity planning and simulation, where we do exactly this kind of projects. So looking into the future, something changes in the airport environment, and we use simulation to check the impact and find bottlenecks before they occur and optimize before something is built. So very useful tools what we use here, and we use CAST in this respect for our projects. Just to give you an overview of some clients who are users of CAST, or we work together on project with CAST. So you can see we have a worldwide representation. Then just to give you a brief overview on the tools, what CAST comprises. So we have 5 modules which are off the shelf, which is like CAST terminal to simulate passenger processes in airport terminals. Then we have CAST aircraft simulation, which simulates processes on the air side and also on the airspace. And CAST vehicle is a tool to simulate vehicle and ground handling traffic. And then we also have stand allocation and gate allocation functions. It's an own tool to allocate flights to aircraft stands and terminal gates. And then last but not least, we have CAST Express simulation, which is a fast time simulation for terminal facility requirement and capacity planning, which is off the shelf. But CAST Express is also used in the context of our CAST solutions, and they are more customized. So this is like a passenger flow solution and security management solutions we have developed in recent years. And we use in this context simulation not only for planning, but also for close to operations, and even on the day of operations, CAST can support the real-time prediction of traffic situation capacity bottlenecks and brings you in a position to act before something bad happens instead of reacting if you face an issue in operations. The simulation tools we used for the entry-exit system in our projects are mainly CAST Terminal and CAST Express. CAST Express is a very useful tool because it's quite fast. You can make a lot of scenarios because we have to deal with a lot of uncertainties, and we have to trigger these uncertainties in a bandwidth of scenario consideration. And then we have CAST Terminal. So let's say we use CAST Express to dig into the data and to check where are issues. And then we can also go with CAST Terminal to visualize situations and to plan something, plan the layout and so on. And CAST Terminal is also a very good tool for communication with stakeholders. So we have a lot of stakeholders involved. So we have the authorities, we have airport operators, we have the suppliers, we have airlines involved as well. And it's a very useful tool to communicate cause and effect. What does it mean if we change something in our process? Now I will give a brief introduction to entry-exit system. What does it mean? I think most of you might know about it, but I just give you an introduction. So from the background, the European Commission aims for an IT system that enables an optimized border management. And everything should be centralized in an IT system for the whole Schengen area. So, and this is mandatory, the system, and once it's introduced for all airports of the EU Schengen area in the near future. And the planned introduction should be for September 2022. So it's not so far away, so there is still some time to plan for it and to get ready. And so the entry-exit system requires capturing of biometric data and further database checks for non-EU nationals. And this, as you will see, this adds complexity of a new processes and also adds a risk for disruption and low level of service. And airport operators and border control authorities need to ensure that everything is entry-exit system ready. And this is also what we are engaged in when we get such a project to support and answer questions, what will happen and how can we mitigate and what is the best approach. What does it mean entry-exit? So how will the system work? First of all, more data is collected than today. So it's like fingerprints and identity, so face recognition and travel documents, then also the dates of entry and exit into the Schengen area is recorded to make sure in a central system that 90 days in any 180-day period should not be violated. And if it's violated, then there's an entry refusal. And before, if people or non-EU passengers or non-EU persons traveled into the Schengen area, they got a lot of passport stamps. And so the immigration officers always had to count together the numbers and so on, but this is not now obsolete, so they don't need stamps anymore. To whom it will apply, so to non-EU nationals, to people who need a visa and also visa-exempt travelers in the Schengen area. And so there are different approaches how these data is collected and worked through. So either everything can be done at the immigration booth, so manually by the immigration officer, or the process is divided, so some kind of the additional processes are taken over by self-service kiosk, and then the immigration officers is released partly. So these are the two, we call it one-step approach or two-step approach in our presentation. So where does entry-exit happen? It's the Schengen EU external borders, excluding Ireland. So the blue areas, you see the Schengen countries, which are in the Schengen area today. Then we have the gray ones, so Romania, Bulgaria, and Croatia. They get also ready. They are prepared to get ready to be part of the Schengen area. And I heard that Bulgaria even had purchased kiosk already, and they are ready to start the system, let's say, once it started. And even they are not in the Schengen area. Ireland is not part of this because of the special arrangement with UK of the land border to Ireland. The system is in place for immigration and emigration processes, and not only for airports, but also for the land borders and for the sea borders. So even the land borders are, so every truck driver who is has a non-EU pass has to go through this process at the land border. And who is affected by entry-exit? Third country nationals, it's always called. Sometimes when you hear it the first time, okay, what is it? Maybe to make it more clear, I just mentioned the people who are not subject to entry-exit system, and these are the FOMs called, the freedom of movement nationals, and these are all people who have an EU passport and or who are in a non-Schengen country, but in a country which is part of the European Economic Area, which is Liechtenstein, Norway, and Iceland, and also Switzerland. So these are the countries, the country nationals who are not subject to entry-exit. And all others are subject to entry-exits, and these are the third country nationals. And there we have two groups. We have the nationals with visa exempt. This is US or UK or Australia. Visa required is some country, is an example, Turkey or India or China mainland, whatever. What is important here, I think, what to realize is that UK, since Brexit is now all UK citizens also are subject to this process, and there's a lot of traveling between UK and Schengen area, and this really impacts the processes. So once you haven't considered them, and now they fall into this group. If we look into the detailed sub-processes, just to give you an idea what it is. So on arrival at border control, a passenger is using self-service kiosk and or a manned counter. Then the data collection process starts. So travel document data needs to be checked or collected, passport validity data. Then the biometric data need to be collected if they're not in the system already. It's a face image and fingerprints, and then the place of entry-exit is to be recorded, the visa data, and maybe also questions on travel purpose. And then the third process, which is like the check against databases. We have checks today as well, like for Europol and stolen passport national security databases and so on. But also what comes on top now is the entry-exit central database check for identification. This is a database which is set up in the moment. It's not ready yet, but it is set up. This is where the biometric data is stored. Then there's if the data for each passenger needs to be updated, or a new file is created for a passenger for this passport number. And it is created for the first entry and updated for the re-entry. And then it's also creation of an entry-exit entry record. And then there's a decision of entry or refusal. And so this is like all these processes. You can see there's more data to be collected more requests to databases, and overall is more time consuming than the process like it is today. If we look into the process time increase, a lot of talk is talked about this. What does it mean, all these little steps? What does it mean in the processing time? So before EES, what is still today in place, there is a certain processing time with a check by an officer. And if we do it a one-step process that the officer has to do all these activities and collect the data, fingerprints and whatever, there is a high time increase. And if we look for the entry-exit system two-step process, it's like, so there is a time at the kiosk and also a time, so it's distributed between the two processes, but it's not the same like this time before. And just to give you an idea, so we have here ranges for processing time for FOMs. For the EU passengers, processes will not change at all, but for the TCNs. And what we can see here for the, this is an example. So these are range data and example data. I have to say in our projects, we have a wide range of processing times, and somehow countries also interpret the rules in a different way, and layout and the process design is a little bit different. And then this also has impact on assumed processing time. So before EES, and then so the red arrows are the entry exit one step or two step, and you can see it's both increased. And the numbers are now examples, but I just gave some ranges. Now let's look into what might happen without an adequate planning. So just have the idea that we have a checkpoint which is well utilized, and we just say, okay, maybe we have some space here we can use whatever. Maybe it will be okay. When we do such a project, we do a test with a digital twin, which is a simulation model. Which enables us to proactive plan and help the airport to be prepared for the upcoming change, let's say. So such a model also facilitates stakeholder discussion, and you can use it to optimize the layout. So even you don't know exactly what is the situation, you can try and error and do a lot of what-if scenarios. What is the best approach? And certainly in this way, you can reduce the risk of disruption already in the beginning, because you can understand where are the things to manipulate, what kind of chances do we have to change this process. And for the key performance indicators, such an analysis gives you, so you can analyze demand levels and peaks, the waiting time and queues, and the resource and staffing requirements. And usually we set up the baseline model first, and then to calibrate it. This is an example here of an example airport. What you can see here, so this is like an anonymized airport, or it's like abstracted, because it's difficult to show the real airport cases because it's still not in place. And what you can see here is an area where we have the handling area for the non-EU nationals, so the TCN booths, and this is the blue and the green are the areas for EU passengers. And you know, EU passengers, so most of them, they have, so they have the electronic passport, they can use e-gates, but there's always a certain share of passengers who cannot use e-gates, like family with kids, or also persons who have an issue with their passport or whatever. So this is like the setup we are looking at, and what we can see here, it's we have a situation, there's a peak situation of this airport where, but it's still good to manage. So we have like this area, the people fit into the system. We have not a nice waiting time of around below 30 minutes, but it's still acceptable and it fits. So now we look into the scenario do minimum. This means that the booths are equipped now with the technical equipment for the fingerprint reader and passport scanners and so on, additional, and the connection to the entry-exit system database. So the IT is installed, and then hope was good, but we can see what is happening because we have longer processing time and queues are back and it accumulates. So we have a certain things what we can observe also, if you look into the following processes like the baggage reclaim, so it will have an impact on the baggage reclaim area because people are stuck in this queue, or if you think about even about transfer passengers, it will mess up a process certainly. So it should also be in the interest of an airline who handles transfer passengers that this process is smooth. What we can see here as well in this simulation, so we have like even from two sides, so we have from the contact stands, passengers and coming in, and also bus gates, and this is like from two areas, so it's a quite unpleasant situation overall what we could observe here. So in summary, what we can see, so the result is like overcrowded area and very long waiting time. If we do it in terms of what we observed in this case, the same traffic, but just introduction of so the same peak, the same flight schedule, simulating it with this entry-exit process means here 25 to 30 minutes, still manageable, but in the other scenario is 1 to 1.5 hours waiting time, which is not very pleasant and acceptable. And I think if you are an airport and you still have capacity in space and in waiting time, whatever, or have additional booths, maybe it will work. But if you have peaks which where you hit boundaries in terms of queue space and waiting time, then definitely you should look into this expansion. So we have to build more booths. What is needed to prevent chaos? If we still stick with a one-step process and we don't want to look into kiosk yet, we have also looked into this. In this example, we have to say certainly it depends on the shares, on the processing time, on the environment, and so on. This is a good representative example where we show the pre-EES situation compared with the EES situation, and what we can see here. So we have 8 plus 2 manned position in this scenario, so an acceptable level of service. And here we need 14 plus 2. So, and this is like what we need from space, from space view and from a counter view, and which is most important, you need more officers. So in summary, for the one-step process, the challenges and disadvantages of a one-step process, certainly expansion is needed. And this may also include to remove other functions. I think if we look into the kiosk situation, we certainly also need space. But so here we need many more counters and corresponding queuing, and also more staff resources. I think this is critical. And the staff resources is a critical element in at every project we have looked in. And there's also a risk because there's also uncertainty about the share of TCNs per flight, and maybe for certain flights it's higher than for others, and it's very difficult to plan and to staff for this, so it's volatile. And if you have insufficient staffing anyway, so you may have built a lot of counters, but you can staff everything, then you would face with long queues and waiting time. So now is the question, what can self-service solution offer to release the situation? And for this question, I would like to give the presentation to our colleague from Seconet.
Thank you very much. Let me quickly share my screen. So, thank you very much. So, my name is Frank Steffens. I work for Seconet. Before I start with actual self-service technology, let me give you a brief overview about who we are. So, Seconet is Germany's leading cybersecurity company. We are one of very few IT security partners of the Federal Republic of Germany. We are a completely based German company. We have offices at 12 locations here in Germany with more than 800 experts working in the whole area of IT security. The company itself is structured into 5 divisions, and one of the divisions where I am working in is the division called Homeland Security. And there we have a very strong focus on areas around biometrics, travel documents, electronic identities, and so on. And of course, these all play an important part of border control. So we are a supplier of border control solution in 12 European countries currently. One example you may have heard of is the German ABC gate installation called EasyPass. You see on that picture on the right side, that's not from Germany, but that's our latest installation in Bulgaria at Sofia Airport. So these are the solutions we are offering here. So let's go into details about the self-service process. When we are talking about self-service solution in general, it's important not only to keep the airport or the airline and the traveler in the view, but it's also is an important element for the border control and the border guard itself. So we have got various feedback from our customers, which is usually the border control authority, that they do not want to become their officers to become some kind of clerk doing only the technical stuff, operating devices and concentrating on all the technical things, but they want to, let's say, have their border guards doing their original job, making the right decision if someone is allowed to cross the border or not. So in summary, you could also have a view on our white paper where all these benefits and advantages for kiosks are summarized. You see that link below there, so feel free to take a look at that. So when we are talking about a two-step approach, so what means two-step? The first step is, of course, at the kiosk. I will show you now how this could look like, or generally looks like. So from the perspective of a traveler, the first thing is, of course, it is an interactive, let's say, device or machine. So, of course, it has a feedback where the user can interact with. What is important to notice here that the user group itself is very international. So, of course, you have to make sure that you are targeting those user group with a multilingual language, not only displaying things in English, but also in other languages, even with characters that are non-Latin. So this is usually the start of the process. Then the first step of this process is the document verification. What I would like to point out here is that those passports that the user or the traveler puts on here are not only being read out alphanumerically. This could be done very quickly, of course, but this is a thorough check of the optical security itself. So it means that such a device typically has a so-called full-page reader integrated, and this is also a regulation or a requirement from the EES regulation. Kiosk users must use an electronic passport, so also the chip is read out from these passports and digitally verified with all the signatures being valid. What we have seen from our ABC gates and our ABC project is that this is a very crucial step in the overall process, because the user has to manage to put this passport on the document reader in the right way and keep it there for a while. Typically, you will see later, the chip reading takes a couple of seconds time, and it's important that the user does not remove the passport too early, for example. So this is why we provide also a very good user interface here and to guide the passenger with live view and a kind of scanning visualization. So the next step then is the capturing of the facial image. We do it in our solution with a height adjustment camera system. The reason to do this is because the entry-exit requires very strict quality of the biometric image. It must be, let's say, passport quality. The deviation of the camera angle must not exceed 5 degrees, for example. What is also important here is to provide a good user feedback. We do this with a digital mirror. That means we have an actual extra display there below the camera where the user sees his own face, his own live video, and then can position himself correctly And yeah, this definitely helps to get a good picture. What is also advisable here is to do a so-called presentation attack detection. That means that the system should detect if a user tries to forge the system by presenting, for example, a printed out photo in front of the camera. So this is an element which is also important, of course, for the user, for the border guard in the end. So the next step then is fingerprint acquisition. Here we go back to the fingerprint reader, which is then on the right side of the system in our case. We also do this with support of the live stream of the actual fingerprints. The EES regulation requires that 4 fingerprints of the right hand are captured. And here we also have the possibility, or we advise to also include a device which has the same level of liveness detection, so to prevent that someone puts some fake fingerprints on the scanner, and this should be detected. Then we have an optional step, which is not required by the EES regulation, but in the discussions with our customers could play a role here. And this is a questionnaire. The idea here is to present the passenger with a set of questions in his own language. And the user can then answer all these questions. And all the answers are then again presented to the border guard so that we overcome language barriers, for example, between, for example, Chinese people where the German border guard doesn't speak Chinese. So then he has a lot more information about what the actual traveler has answered here in the questionnaire. At the last step, it's also important to understand that the kiosk can also play a role in passenger guidance. For example, it's not necessarily the case that the traveler has to proceed to a manual booth, but if he fulfills, or he or she fulfills certain requirements, for example, it is a re-entry, he's kind of a, let's say, bona fide user group, then it could also be the case that he is directed to an ABC gate, where he proceeds there's a process and crosses the border via such an ABC gate or E-gate. But let's assume we have the case that the traveler goes to the border guard at the desk. Then the border guard has his own border control application where he retrieves the data that was captured on the kiosk. And this could be done in several different ways. At least there are 2 major ones. The one is use it with the scan of the passport again. So the data from the so-called machine-readable zone can be used to retrieve all the data that has been stored from the kiosk and then displayed it to the border guard. Another alternative could be that we do this retrieval of the kiosk data via biometrics. So, for example, consider the case that there's the camera at the border control booth who is capturing the passenger while he approaches the desk. And then with a small biometric identification, it would also be possible to display the actual passenger record from the kiosk to the border guard based on the image of this camera that has been captured the face of the traveler. One thing that we usually see in Northern America is the use of a printout. But this is something we wouldn't advise here in this case because we don't see real benefit compared to the first one with the passport. So once the kiosk data is displayed to the border guard typically verifies this data and decides if the passenger is allowed to enter or leave the country. What is important here to know is that the border guard has also check the results of the central EES system. So this is an important step and also a time-consuming step because when we have the situation that the traveler arrived for the first time and his data has not been recorded yet in the entry-exit system, then the requirement or the EES regulation says that there must be a full identification of the newly captured biometric data against the whole EES database. And this can take a couple of seconds. Nobody knows exactly how much, but let's say 20 or 30 seconds, this could easily be. And this long-lasting query could be done right after the kiosk data has been submitted. So from the whole process point of view, this identification in the central background takes place between the time when the passenger has left the kiosk and appeared at the border control desk again. So this is clearly one thing that is an advantage when using this two-step process. Okay, some timings about current or pilot projects that we've done so far. You see on the top, we had a land border project where a kiosk was placed at the land border, and you see that the green area is missing here. The green one is the questionnaire. That is because in this pilot there was no questionnaire, and you could also see that the gray area, the other interaction, is quite small compared to the other one. And this is also the case because there was an assistance in using the kiosk. So another, let's say, trained personnel was helping all the passengers in their kiosk operation itself. So it really depends on how to implement such a kiosk process. The questionnaire can take a while or not. This really depends on how many questions you ask, and also the other interaction really depends on how the process at the kiosk itself is structured. So a lot of options how to design the process, and with that I hand over to you, Mark.
Thank you. So this is Mark Illink from ARC. I'm also working in the consultancy team of ARC, and I'm supporting many airports in Europe and all around the world for capacity studies, and in these days, in particular, regarding the entry-exit system. And yeah, I think it sounds quite interesting what Frank said, and it might be very interesting, especially for airports which are short of staff or short of areas to outsource these time-consuming and repetitive activities to kiosk or other self-service options. And we used our simulation tool now to also test the capacity impact of such a new system and also see the potential, what it could deliver, and finally to get an idea what is the best implementation for an airport. But before we look at the kiosk implementation, our demonstration model, I quickly want to remind you on what options we have seen so far. So if an airport does almost nothing, so no expansion, just the technical equipment of the booth, we saw it is often the case that the service quality cannot be as good as desired, and it causes some chaos. The alternative would be to have a major increase in officer positions, which require trained people, but also space in the immigration area, which is not so easy to offer for an airport. So both options are not really satisfying. And this is why when we see this, we can use a simulation tool to search for alternative options or better options. And this is now a situation where we used our simulation tool as a test bed to implement such a new process like our immigration kiosks. You see here this area, we for simplicity reasons, we put it here first, and you see that the TCN passengers approach these kiosks first before they continue their journey to the manned positions here. One benefit you see already in this simulation is that these short moment demands, which we often see after flight arrival, this is all happening at the kiosks, and the throughput to the officers is now limited a little bit. And you can think of that these kiosks act a little bit as a buffer, and it means we do not need as many officer positions as we saw on the one-step process. So the processing times indicated already that in the two-step process, the time at an officer per person can be reduced compared to the one-step, and also the kiosk act as a limitation. So in the end, the expansion in terms of officer positions would be definitely lower, and maybe, depending on the starting point of our airport, maybe even the existing number of positions could be sufficient as we see it here. So you see, this is a quite nice example how we could use a simulation for very new processes, which an airport has never tried in reality. And here, even with a 3D animation, you can visualize it and also communicate it to the different stakeholders. So the idea of these kiosks are also that the areas which they can be positioned are not so fixed as it happens for the counters. The counters, they must be added here in the immigration area, which might include removal of some important areas, shops or whatever. But with the kiosk, an airport is much more flexible, because kiosks could also be put in existing arrival corridors, or other minor areas like offices could be removed somewhere else. And then it is not so difficult to place them somewhere. We even have seen some successful installations in other countries, so not in Europe, but United States or Canada, where kiosks are more often used today, where different checkpoints of kiosks worked quite well. Certainly a floor walker would be needed to organize the flows, but this could also be an option to make best use of the available space and then find a solution which is suitable for each individual airport. To summarize quickly our scenarios which we looked at, and also to show you how such a simulation study or calculation study could support you. The idea of such a study is really that in the end, each airport gets an individual decision board like this. So we have maybe our starting position with 8 + 2 manned positions, and then we could calculate with this tool the different alternatives, either as a one-step, where we ended up with 14 positions here, or in a two-step, it is less, maybe 8 to 10 positions, officers, but then a few kiosks. So in the end, it's such a decision table which we can offer to our clients, and then the best solution can be picked. But again, it's important to mention this is not one rule of thumb which applies for each airport in the same way, but it's always an individual calculation, because local conditions change, the flight schedules are different, processing times, process design is different. So this must be calculated for each airport individually. As we said, we have done many projects with the different airports. We can also show you a little bit how to proceed now, or what we recommend how to proceed if no planning has been, or less planning has been done so far. Some best practices or lessons learned, some examples and sensitivities we also show of some things which you might not have thought of. In general, when we want to redesign our checkpoint, we have the objective that our checkpoint is robust and efficient. From a passenger perspective, it means it should offer a continued high passenger comfort, which means reasonable waiting times and queues, no blocking of any areas, no passengers complaining about the waiting time or missing their transfer flights. So this is one very important key performance indicator, and this should be also reached under all conditions. From an operator perspective, we need a cost-efficient setup. So the checkpoint should also not be over-designed, but it should just be balanced to the demand. And the typical approach to fulfill all these objectives would be that we really start with a good analysis of the baseline, understand the local conditions, maybe even set up such a calculation or simulation model for the current situation and calibrate it, that the model is really a good indicator of what is happening. And only then we can also apply these new rules, which basically means adjust the processing times or also adjust other parameters in the model, and then analyze the situation and identify, is there a capacity bottleneck, or are we in the lucky position that the checkpoint is still big enough and maybe even offers spare capacity? But very often, unfortunately, this is not the case. We see some bottlenecks also, as we have seen it in the previous videos. And then it's always a question, what are our potential actions? How many new counters or how many new kiosks are needed to be built? So we can do these calculations with the software. And what is very important to get such a robust checkpoint I mentioned, this number which we calculate should be high enough that even if some parameters change in the end, and we have not really assumed data like this, the checkpoint should still work fine. So these sensitivities testing is highly recommended. And I'm also showing you some examples how sensitive such a checkpoint could be. And finally, when the checkpoint is planned, it doesn't mean that's it, but simulation or calculation should also continue for supporting the operational people. So staffing would change from day to day, from season to season, and we could even apply simulation models or our own cast solutions to continuously calculate what is needed and always balance demand and capacity in a good way to fulfill our targets above. Okay, quickly some lessons learned, what we saw in our previous processes for the different questions or for the different working steps from the previous slide. One question is always, how much do we need to expand? In this case, how many kiosks would we need to build? And how could such a question be answered if we say that 10 minutes is our target? Well, we could look at the maximum waiting time, what is often done, and then we would say, okay, in our example, the first time all passengers do not exceed 10 minutes, it requires 28 kiosks to do it. But very often we have seen that making sure that all passengers do not exceed these waiting times is not the most efficient way. So the simulation would also allow us to get individual numbers for the passengers and look at our waiting time distribution in such a way. And then the conclusion could also be, maybe it's still acceptable for us to allow that a slow percentage of passengers, maybe 5%, wait a little bit longer, and then 24 kiosks could be a good proposal. So the message would be making sure that everybody is inside this category is sometimes very costly, and compromise is often the better solution when a new checkpoint is designed. A similar decision could also be done for space. Whatever is more limiting, we could also find out how many kiosks are needed that the queue doesn't reach out of this dedicated queuing area anymore. So this is also a result of the simulation. And what we have seen here, it's there's sometimes one point where adding more facilities does not really change the queue length anymore. So you can put more and more kiosks in the building, your queue will be almost similar. And this is also understandable, especially when we talk about bus deboarding. Your whole number of passengers would be in this area at one time, and then it almost doesn't make a big difference how many kiosks or how many counters are standing there. You just have these passengers in the area, and it means you cannot, at some point, you cannot reduce your queuing area further because they will always be there, even if we offer more service, more kiosks. One other question is also then, in particular, when we talk about two-step, is balancing. You could think of the more kiosks we put in, the better. But you see at these charts here, which show us the waiting times at kiosks and at counters, that yes, for kiosk, it's the case that the more kiosk we implement, the shorter the waiting times get. So this is true, but waiting times at the following counters, they get higher and higher then. And this is also understandable because when the kiosks do not limit the flow, but let all passengers much faster to the counters, then we have the queues at the counters again. So it's also quite good and recommended to look at such a combined system in a combined way and know about the interdependencies of kiosks and immigration counters, or what Uta mentioned, you could even look at the baggage reclaim hall, because this is also impacted by what we do at immigrations here. So the combined way is always recommended. Then we talked about a robust checkpoint, and why is this important? Well, it's a new process. The EES system is not implemented at any airport yet, and there have also not been so many test checkpoints, which means we still have uncertainties in data, which could mean processing times, passport shares, or also those passengers who have their first entry or second entry, because processing times would also differ a little bit if the system registered them for a first time or if it's a re-entry. Then we also have some flexibility in the process design. We have seen we can implement it as one-step or two-step, but even when we decide, let's say, for a two-step process, we would still have some flexibility. What is done at the kiosk, so how many questions are asked there, or are the questions rather asked at the booth? Balancing of sub-processors, we have seen at the previous slide, has an impact. And finally, we can plan as good as we can, but in reality, there will always be additional operational uncertainties. The flight schedule changes over the season. Even the actual flight schedule, so the on-time performance, will change. Sometimes flights arrive early, sometimes flights arrive late, which makes a difference. We have also some fluctuation of the passenger type on the flight. So you could imagine a flight from Antalya. If it's holiday season, maybe it's full of tourists, which are easy to handle, but it's off season. Maybe we have many people from Turkey visiting their families there, and then they need longer to be controlled. So there are some changes, and certainly we also have some boundary conditions, how the checkpoint could be staffed. So these are many uncertainties, and we recommend doing many tests and also change all these parameters. Some examples in this direction. We have seen that many calculations start with one overall passport share. So you see it here, it's always the same share of FOM and TCN passengers, which might apply for some flights. But as I said, we know there are sometimes touristic flights where there are much more European travelers on, and then there are some other flights, ethnic flights we call them, where we have many TCN passengers on board. And when we apply these different or these detailed passport shares to the same flights, we could see sometimes peak have more FOM passengers, sometimes peaks have more TCN passengers, and the effect is considerable. with overall passports, maybe we end up with 30 minutes processing time, which could still be acceptable. But when we then apply these detailed numbers, and this is what we really did in realistic projects, we end up with double the processing times, double the waiting times. And I think this is a very, very important statement, that calculating with detailed numbers is very important. Otherwise, we could we would have the risk that we do not identify these detailed patterns. Something similar would also happen when we talk about processing times. So currently the numbers are from some limited test installations, or they also include some assumptions. So we are currently still a little bit unsure how these processing times develop. And an example could be if the processing time is just 30 seconds more, so 2 minutes 15 instead of 1 minute 45, how sensitive does it get? And you see a similar picture here with a slightly lower processing time. Maybe everything is still fine, but a little higher processing time again shows double the waiting time. So there's higher sensitivity, which means it's not recommended to only do one calculation and that's it, but always look at potential other situations and plan with some safety buffer. Okay, we are almost off time, so I'm handing over to Uta for the last slides here, and then I hope you still have a little bit more time for questions and answers then.
Okay, so thank you, Mark, for this very interesting, insightful presentation. So we don't have much time left, but I think we can talk about an outlook for operational support, also with CAST solutions, what we see as a good benefit. And so as I mentioned in the beginning, we have a CAST solution, which is an operational support for passenger flow solution, which can be also applied to immigration or immigration process. Idea behind is a digital twin of passenger processes. We can even use the same model we have set up in our planning project, but then connected to databases as well, to operational databases. And then we can have a proactive planning, we can do real-time prediction and operational management. And this is done by optimizing planning of resources and providing the situation awareness which is needed, and also enable the user to do what-if analysis for testing possible operational concepts and their effective on operations. So I just give you an idea how this could look like. If like this CAST Express model is integrated in the airport's IT environment, so there is a connection to the airport database with flight updates and resource usage. Then CAST can provide regular real-time prediction on the day of operation. Let's say every 5 minutes it's getting flight updates on actual time of arrival of aircraft. And then it can predict the passenger volume, the waiting time, queue lengths, and needed resources for the day of operations. And let's say you can already know when a flight is departing too late in New York, flying to London, then or to Frankfurt or whatever, you would already know that the flight will be delayed, and then then some flights are earlier and some flights are on time, and you can just predict what is the demand in a certain immigration area. And then there could be also an alarm, and there might be other planners who use CAST Express directly and do what-if scenarios. So they can see, okay, there's an issue, and then just they get on the phone and say, maybe I will try, if the immigration officers go half an hour later into break, we can prevent the chaos, let's say. So it's an easy task, just operational. Or you can just say, I assume that we can send 2 immigration officers from immigration area to immigration area for half an hour to resolve this peak. And this really brings you in a position to act instead of reacting, and prevent early enough these things. And so you can come from bad situation to green situation just by operational measures and learning with the system. And then certainly if the results could be also available via the internet, so the stakeholders like the immigration duty manager could also see the results and act on the spaces. So this is the main idea behind it. And this could be quite powerful. There is one thing certainly for the data which is there, so like the TCN shares on flights, but I think data is there. It should be just from the beginning discussed, let's say. So when I summarize our webinar, I can also go to this data question. We can see that there is a certain complexity. So we have many new sub-processes, we have dependencies and parameters, and also the stakeholders like border authorities, the airports, airlines, and the suppliers certainly as well. And we have these uncertainties. We have to deal with passport shares, processing time, and operational contingency. Operational contingency means not sufficient staffing or flight arrival times fluctuate, and also user shares and so on. And then, so the recommendation, what we think is a good approach, is to collaborate with the stakeholders from the beginning, and also for the individual data collection. So each airport is different, and what we see and learn from our study is the proportion of TCN passengers is very individual by airports. It depends on the traffic mix, it depends on the peak structures. And therefore we always analyze peak structures, and it may be that not in the absolute peak is the biggest problem, but maybe in a side peak where you have a lot of, or you have several flights arriving with a high TCN share, and then focus on this, how to solve this, and not operate like you did before. And based on this, when we have a good database and discussed the data and the scenarios, even it's not known, but we can do scenarios. We can do capacity calculation and sensitivity tests for robust planning. And we would recommend then also base your discussion, buying hardware and implement hardware, also have this knowledge about what to expect. And based on this, also train staff and plan everything. And then last but not least, also think about how you can make a good demand and capacity balancing on day of operations, because as we explained, there will be, it's a volatile process, it will be, will stay volatile. And especially if the processing times are getting so high, it's pretty easy that you get issues and level of service problems. Okay, I think we are almost on time, not really, but before we close, I also want to, before we come to questions, more questions, I would like to guide you to the next webinars if you are interested. So you can just go to our website and check if you like to participate in other webinars in April and in May. We talk about airside planning and capacity assessment with CAST aircraft simulation, and also infrastructure and resource planning with CAST vehicle ground handling. So if you're interested to learn a little bit more about the questions over there, you are very welcome to participate. And so in the name of everybody here presenting, we thank you for your attention. And I think now, if who likes to stay, I know we are 4 minutes over time, but who likes to stay also to raise some more questions and we can answer, maybe you can just stay. I think there was one question for Frank, which was?
Yes.
Yeah.
Yes, so the question was, what is the usual lead time to deploy and integrate your equipment once a customer requests a deployment and do a fully tested and activation for real operation? So I think the key element in such a project is the integration of all the software and the process of such a kiosk solution. As you've seen on the slides, the data that is captured by the kiosk must be integrated somehow into the actual border control process at the desk. So this means the actual usually the existing border control application has to be adapted and modified. And I think this is the key element to set up such a project. The kiosk hardware itself is very quickly deployed. Based that everything is planned regarding where to put them and everything is cleared and there's power and network. It's just a matter to transport them there and then plug them into the power and the local network. But actually, what requires planning and testing is actually the whole process flow about what happens when the data that has been captured, where is it stored, how does the overall system connects to the central European entry and exit system, and how does the actual data find its way into the border control application. And this is the key element for let's say deployment or implementation of such a two-step process.
Thank you very much. So maybe one question which is also related to this. So there is a question, no lead time for hardware. You have available stock all the time.
Yes, so we planned a little bit in advance. We are currently in the lucky situation that we can deliver kiosk. Yeah, so this is just my situation or the situation of us here at SecureNet. And I know that the overall market situation is quite challenging. So I can only speak for my company. And yes, we are currently in a position that we can deliver out of stock.
Maybe just one more question to you before we move to cast questions related. So how do you clean the glass at the kiosk after the fingerprints are taken from one customer before the next customer puts down his hand?
Yeah, so actually it's an interesting question because the actual EES regulation, which was written before COVID, obviously, requires that a contact-based fingerprint scanner is required there. So nowadays, there's also let's say the technical possibility to use touchless fingerprint scanners. But my personal opinion on that is that there are fewer devices on the market, and it's still not allowed for the entry exit. So we have to stick to a contact-based fingerprint scanner. And yeah, cleaning could be done, of course, manually. Could also be done with some, let's say, hardware assistance. There are some devices who have a special foil on top of their plate. There's also could be the possibility to use some UV light cleaning mechanism. So there's no, let's say, general way how to clean the glass. But in the end, you're right, it is an issue that someone has to think about.
Thank you very much. So I think the next question would be more directed to Mark. It's written, you mainly showed inbound processes. How is the expected situation at outbound passport control, and can the same be simulated for outbound processes?
Yeah, certainly. So entry-exit system would also apply for outbound processes, not exactly in the same way as for inbound, because in the end, everybody who leaves this country will also be registered in the system already. So it's not storing the data again and making these database checks against facial data or fingerprints, which takes the long time. So it will be a little bit simplified at outbound passport control later on, but there will be a certain phase where even the outbound passport control might be the more problematic one. And this is the starting phase when not everybody is registered in this database yet, and the full process also needs to be done at outbound passport control. And from an overall perspective, the outbound passport control could even be more critical, because when long waiting times occur at inbound, okay, our passengers have to wait, and it's maybe not nice for them, but it's more or less the last process in the chain, and then they go home. accept transfers. But for outbound flights, when we have these long queues or waiting times, when passengers want to fly, they could miss their flight, and this is not wanted by the passenger, not wanted by the airline, so it could even be more problematic. So yes, we could also simulate outbound processes, and we would even say that looking at the different interdependencies is even more important here. So does it mean we need to even have additional lanes there, fast tracks for some passengers who are late, or do we even need to adjust the last acceptance time at check-in? So there are many additional questions which are linked to this departure flow as well.
And also transfer arrival. So if you have transfers coming in from a non-Schengen destination and need to go to transfer immigration, then this certainly is also an important area to look at.
And I can also add that even currently without the EES, we have some ABC gate or E-gate installations where the use of certain TCN groups is allowed for leaving the country. So this plays also an element here, because these ABC gate installation would then have to be slightly updated or modified from the software point of view, that when the EES is in operation, that they, as an additional step, also record the exit event to the EES of the passenger and perform the required biometric verification towards the EES that the correct passenger is leaving the country here.
Okay, great. Anastasia, was there another question?
So thank you very much for the answer. So another one was, how could you get this the passport shares? I think this also applies to what Mark was explaining.
So this is a tricky part always. So sometimes, so we had projects where we got pretty good data. So it was collected by statistics by border police. Usually a border police can have so our preferred approach would be to have statistics on TCN shares by flight, let's say, or flight number. And as far as we know, they could provide data because they don't ask, they cannot identify if several flights arrive, who is on which flight. So you can also get statistics on certain time intervals. If you say on a Tuesday in summer, there is a certain pattern, you could apply and learn from this. If you get the data, certainly, and if the authorities allow you to analyze, or they can analyze. What is quite important to understand, so if this data is shared somehow, then your planning reliability will improve tremendously. And what kind of data needs to be shared? So it's certainly a data protection issue, but it has nothing to do with, we need to know that a certain passenger, Mr. Meyer, was immigrating at that checkpoint then and then, but we only need, there was a flight arriving from London and there were a share of 20% TCNs typically. And this is all the information needed to make a better prediction. And also I know that airlines, certainly they should have the best data because they also collect this data with API information. And we also discussed this, that airlines are not always keen on sharing this data as well. But essentially it would certainly improve in the stakeholder discussion if they would accept that it has a certain benefit to their passengers, at least, because an airline is not so much interested if they don't have transfer passengers. If they arrive at an airport and the passenger is in the queue, it's not the business of the airline anymore. But certainly if they would share the data, so if there is a good communication with border police and airports and airline and this discussion going on, you can get this data. And otherwise, so what we would not recommend really is to apply one share for all flights. Let's say the annual share of TCNs is 20% at an airport. I would not recommend to to use this, rather look into the peak structure of an airport, and maybe not the highest, worst peak is in the main peak, but maybe it's in the side peak. And this to understand is important. And we also got quite good assumptions. So you can get this from observation, also from interviews, because airport operator knows when, oh, there's a flight arriving from China in the early morning, and this always creates mess because everybody's a TCN, let's say. So a lot of common sense can also be applied in defining this if you don't have the data. And plus, I know we also did a project with IATA, and they also had very creative approach and data from ticket purchases. They have all over the world. They handle the ticket purchases, and then you can also make assumptions based on this, where a ticket was bought. That's a nationality, and this kind of, I would say, detour possibility to get more information on this data is also possible. So I would say it's not impossible to get better data than an average annual share, which is a very critical planning assumptions for sure.
Yes, okay, good. Just another question pops up. If the kiosks are placed in an aisle, there could be issues of congestion if passengers stopped in front of the first devices. Do the second devices provide some kind of signage to make it easier to identify free units?
Yes, they do. And maybe you've noticed the detail in the slides that we have some LED guidance on the where the passport elements and the document and the fingerprint scanner is. So we can use that. So, for example, both can be green to signal that such a device is ready to use. Of course, we could also use the screen of the facial camera system, which is a little bit higher, to signal that the kiosk is usable. So that is doable, yes.
Okay, thank you very much. So if I'm right, I think this was the last question for today.
Yeah, and the ones who are still in the meeting, still 50 people, amazing. Thank you very much for your participation, and it shows us that there is a big interest. And if there's anything we can do for you, and answering questions, and also following up discussion, exchange knowledge. So we are always happy to discuss about this. Certainly a lot of knowledge is there everywhere in our airport community. And it's good to share and to discuss experiences. And so you are very welcome to contact us, and we are happy to answer questions what we can, and have a good discussion with you. So thank you so much also for Mark and for Frank for sharing their insights and knowledge. And so far, I wish everybody a very nice day, and yeah, a good planning for the future of when entry-exit will be part of the process with the airports. Thank you very much.
Thank you. Bye-bye.
Bye.
Bye-bye.